Imagine your doctor discovering that you have a life-threatening disease, but then telling you that there's no reason to panic because they can fix it simply by editing it out of your genes and DNA.
New treatment for sickle cell anemia uses the power of gene editing.
Red blood cells are like a disc, almost like a frisbee, if you will. And in sickle cell disease, what happens is the hemoglobin molecules inside that cell snap together like Legos. And when they do that, they can change the shape of that cell from a frisbee to a more sickle form, a banana shape or curved shape, which is what the disease gets its name from, of course.
Because the red blood cells are that crescent shape, they don't live as long and they don't carry oxygen very well.
A shortened red blood cell lifespan results in a cascade of events occurring in the body: chronic anemia, severe pain, strokes, fatigue, decreased lung function, kidney function, heart function, and ultimately for the adults, a decreased lifespan. In the last decade, there's been an explosion in the options to cure sickle cell disease. And the science is as elegant as it gets in human work. So you can take somebody's cell, fix that person's cell, put that cell back into that individual, and they're going to be cured of that disease. That is just a beautiful concept that we all dream about.
This is a completely new way of thinking about sickle cell, and engaging patients in these conversations is so important.
Within the US, there's 100,000 people living with sickle cell disease. Globally, there are around 20 to 30 million people living with sickle cell disease.
Sickle cell disease has sub-Saharan Africa as its epicenter, as well as the Middle East, India, and countries around the Mediterranean because of the high density of malaria. Individuals who had sickle cell trait were protected from developing life-threatening malaria. And so, as a result of evolutionary pressure, these are the regions that have the highest density of sickle cell disease. And then, because of forced migration, enslavement, you have populations with sickle cell disease all over the world. The reality is, the majority of children and adults with sickle cell disease do not get the level of care that they need, even in high-income countries. You can't identify a more strident example of health equity than how the healthcare system treats individuals with sickle cell disease. They are the canary in the coal mine for health equity.
When you get down to the lived patient experience of being in a hospital and essentially being triaged as though your pain is not real, that is a whole other condition into itself.
I have a PhD from Duke. I have to actually dress up in my Duke gear. Not the I can buy this at Walmart shirt Duke gear, but that I know that somebody in the medical facility knows they must have got that on campus just to be treated like, like I know what I'm talking about.
Racial disparities are a huge part of the conversation. I get the feeling I actually know we'd be further along if, it wasn't a thing. Sickle cell is the oldest described molecular disorder. There have been disorders discovered after the fact that have more treatment options in terms of research and care.
For decades, there was no disease-modifying therapy. We were just watching individuals with sickle cell disease come to us with acute care needs. And then in the mid-90s, there was a therapy referred to as hydroxyurea that was demonstrated to decrease the rate of pain, the life-threatening complication of the lung, and the rate of transfusions. So this was a real breakthrough.
Hydroxyurea does many things, but essentially it raises your fetal hemoglobin. When the mother is pregnant, this is the type of hemoglobin that is used to carry oxygen throughout the body. After a baby is born, that fetal hemoglobin switches off and adult hemoglobin kicks in. And that's where sickle cell kicks in. The other part of the story and what's being researched today is increasing fetal hemoglobin through gene therapy.